so that initialization only takes about a minute and a half to do, and we're all good. So basically, if you walk up to the instrument and the green light's on here and the green light, these are sort of coupled together. It's your measure green is, you know, good to go light. Then you're ready to roll. So what I like to kind of start with is, you see over on the left side, these are sort of your function buttons. What do you want to do? All right, and I'll kind of go through each one of those. And then up here above your video window, these are sort of what do you want to see. Okay, so it just controls what's actually displayed on the screen. If I take this sample, just for instance, I can touch this with my hand. Okay. Comes with a little tray here. It's designed to help you align samples. Since this doesn't have an XY programmable stage, the idea here is that you put your sample right in the bullseye, and then when you push it in, this kind of curved line lines up with the front of the unit, and that way it's going to put it right under the video screen. So just something you don't have to use, but it's just convenient, especially until you get used to where the X-ray beam is. So I'll just put it right there in the bullseye. And then you can open the door, or if it's a pretty small sample, it'll probably just slide right in. But you see, I can only open the door as far as the head allows. We wanted to avoid a pinch point here, so the head's pretty far down, because you're gonna be focusing only a ½ inch from the bottom of that X-ray head to the top of your sample. All right, because we want to be pretty close to the sample.
Just maximum height is a ½ inch from it.
Yes. So maximum height of the area that You're at a ½ inch above the sample. So if you have anything protruding more than a ½ inch up, then you're not going to be able to measure in that recessed area. But this head goes up. Like I said, the head goes up to about 6 inches.
Oh, 6 inches?
Yeah. But always the bottom of the head needs to be a ½ inch away from the area you're measuring. And while I'm doing this, I'll show you also that. You see the head going up, and so that's all the way. So you've got, I tell people you got about a shoebox of room to put things in here, and then you'll see, you know, there. So there's where the, you see, if you get down here, you can actually see right here there's an aperture open where the X-rays are going in and out, and then there is a steel pan protecting everything. So you could crash into a sample potentially, but it'll detect it and it'll move back. You're not going to damage the machine. But yeah, so you can put something big in there.
So does the machine tell you when you're a ½ inch away from it, or you have to?
Yeah, I'll show you. So we've got a like an autofocus system that'll do it for you. You can adjust the speed of this going up and down. You know, for me, this is a little bit slow, but you know, it's totally up to you, and I can show you where to change that. Okay, so we know we're going to be about a ½ inch away, so I'll just kind of move it down. So again, put it in the bullseye, move it all the way back, and there's our sample, right? And I'll close the door. So, you know, you can just manually move it around. So we're clearly not in focus, right? But we'll get to that. All right, you see this yellow circle? That represents your actual X-ray beam size, okay? Now you've got 4 different beam sizes to choose from on this system. And I set you up with 3 different beam sizes or spot sizes, whatever you want to call it, depending on the feature size that you're looking to measure, okay? So you've got a 12 mil, are you all familiar with the mils, inches? Yeah. So you've got a 12 mil round, you've got a 4 mil round, so you see how I'm selecting this application, and see how it changed that spot size? And then you've got a 2x10, okay? So I set up those 3. You've also got an 8 mil, but really it's a little bit redundant. You know, you could set up the 8 mil as well, but when you have a 4 and a 12, the 8's just a little bit unnecessary in most cases. But the idea here, this is an actual aperture that is limiting the X-rays that can come through that hole. Okay, that's important to note, because the 4 mil versus the 12 mil, the 4 mil just isn't going to get as many X-rays to the sample. All right, because they're just limited by the size of that hole. All right, it's, you know, pi r squared is based on the area of the hole, how many X-rays, you know, the flux you're going to get to your sample. The more flux, the better the performance is going to be. Okay, so you always want to use the 12 mil when you can, but if you have a small feature you're measuring, you want to make sure your collimator, we call it, or the spot size, is half or less the size of the feature you're measuring, right? That gives you a little bit of wiggle room to where you don't have to be exactly in the middle, and you could expect accurate results as long as your beam size is half or smaller of the feature you're measuring. This rectangular one would be nice if you had some kind of a connector that's cylindrically shaped. You can go along the axis of it, because when you think about the area, you got 2 by 10, so you basically got a 20 mil area here versus the 4 mil. You got pi r squared, so you've got 4 times pi. You only got about 12 or 13 mils of area, so it's almost double the flux you're going to get out of the 2 by 10 versus the 4 mil. Does that make sense? But like I said, whenever you can, especially on big bulk samples like this, just go ahead and select the 12. I would only go down to the smaller ones when you need to. I'll show you also, there is a zoom feature. You can digitally zoom in and out, so that can help you, align yourself just by scrolling the mouse wheel in and out. So that can help you align things on a small sample. Let me show you how to get this in focus. So we're on the video tab here, and we have our lighting controls here, where you can reduce the brightness. You can also, there's different angled LEDs in there, so if something had a weird shape, you could look at it from an angle. So yeah, I was just doing the slider bar here. If you can't get a good image, you can always go to adjust camera, and this will change some of the camera settings, exposure, gain, that sort of thing. I try to set it up to where you won't need to use that, but it's there if you need it. And then if you were doing a sample that was yellow and you could barely see the crosshairs, you can always change the crosshairs to a different color. So again, all this stuff is just kind of visual preference stuff. Really has nothing to do with the x-rays themselves, but it's just the way you view a sample. And then down here is that Z control to move that head up and down, right? So we got 2 arrows is fast, 1 arrow is slow, okay? So the idea here is you want to be in perfect focus, right? Well, how do we know we're in perfect focus? Well, we got a couple of ways to actually get it to focus to the exact height where we calibrated it, a ½ inch away, all right? You see this AF here? That's an autofocus, so that's actually going to look optically at the image, and it's actually moving the head up and down until it gets it into perfect focus. You see that takes about 8 or 10 seconds to run, right? Another option is we've got this laser right here you can click, and when you turn that on, you see your laser, you just click right in the middle of that, and it'll bring it right into focus, okay? Now something fancy that we just came out with is if you right click on that, you see how now there's a little like laser on it? You can click on it and it'll automatically move the laser for you. That we literally just came out with that, so I tend to forget about it. And you can do the same thing down here on measure. You can turn on auto laser focus to where now, whenever you click measure, it's going to automatically move it into focus and measure. So I like that, but my only hesitance is we literally just came out with it, so I don't know how good it is in the long run. All right, so, but the good old-fashioned auto, or the laser focus, manually clicking on it, as long as the laser's right in the middle, you're in focus, right? So if you notice sometime on this auto thing that it's not moving it to the center, then just stop the measurement, go back and just manually get the laser in the middle. But yeah, try this out, because I'd love your feedback on how well it works. It's been working well for me, but I have seen a couple of times when I was too far away, it didn't do a very good job. So just something to note. So on the 12 mil, I've got it set up to run for 30 seconds, and you can see your results over here. So we got about 4,500 microinches, about 4.5 mils of 10 lead, at about 12.5, 87.5. So that's your results. Also, you see down here, we use this tab idea a lot just to kind of save real estate. So some things or some other views are hidden. If you go to reading, it kind of blows up the current reading. It just kind of makes it bigger. So how did that match up to?
It's a little high, but it's not too far off.
Yeah.
It should be around 9%.
Oh, 9%?
Yeah.
Okay.
Like different spots.
Is that what you did on the point on the?
Again, that's in reference to my machine back
Oh,
there. So
no, but that's
my
on
machine
the
could be a little bit
Yeah,
off.
it could be because.
Oh, you're looking at very
But
small.
it's calibrated to 8.7, and I was consistently getting about 9. But there are certain spots that are high, like 12%, 11%, and then
Oh, is that a standard? Is that a
this is an old standard, an
Oh, it
old,
is?
well, an old calibrated.
Oh.
It hasn't been calibrated since 2001.
So, but it may be the fact that you all have a 60-40 and you have a 3%. You know, so maybe putting one in kind of in the middle
More
could help
spots.
it, but it also may be just that it's, you know, spot to spot. But we can talk about that a little bit. But yeah, and then if you just wanted to move around somewhere else, there's there. And when you're on the reading display, it blows up the current reading and it'll replace that with the next reading. When it gets done, the results is going to show everything in a list. And then again up here, what do you want to see? If you want to look at the spectrum, you can. You can even go down here to PT of E, periodic table of elements, and you can highlight. They got this new feature where when you click on it, it kind of tells you things that it might be, right? Or if you just hover over any of the elements, it'll identify those as well. So, but your statistics are here. You know, you see this is the thickness. Here's the percent 10, percent lead, and then this results tab here just kind of is a concise table with your results. So again, just kind of whatever you want to look at. Now, the way this has a built-in database, so I don't know if you all are going to want to put in things like part number, lot number, things like that. Are you all planning to print reports out from this? Okay, great. So let's say this was a new sample that we were testing for a customer. All right, so we put our sample in, we select the proper application. If it was a really small feature, you know, we'd select the smaller spot size. And then what you want to do is you want to start a new data session. See over here?
Mm-hmm.
Now when you do that, it's going to prompt you to enter in, I just threw this together just the sort of stuff that customers typically use, but you can totally customize these fields. We call them trace fields, so you can just trace the data back. But you can put in anything you want here, and you can just tab right through it. You get the idea. And then when you hit OK, it's going to clear that last session off, but it stored it to the hard drive. When you go up to results, that last session number 2 is right there. And if you go to view trace, you could see anything that, I didn't put anything in for that, but you would see any of the information about that particular data session, right? But the really nice thing about this is if you label it with all the pertinent information about the sample, you can actually search the database by any of those fields and bring up any old data. So if a customer asks for it, it is stored long-term in the system. So basically you search by it and then you hit this little filter button and it'll show you any of the sessions that have that right here on the screen. So running a sample, just doing a test on a sample is relatively easy. Put it in, manually move it around to wherever you want to go. If you need to adjust the lighting, do so. When it's in pretty decent focus, this autofocus seems to work fine. So just get it into decent focus, hit that, and you're rolling. While this is running, there is a calibration standard.
Let me turn on the light then.
Oh, there it is. Thank you. So this is the energy cal. For your Seiko, you probably had something similar. It was called like the manual correction standard. Anyways, this we recommend you run on a monthly or weekly basis. Monthly at a minimum. You could run it on a weekly basis, and I'll show you how to do this. But it's basically, Oh yeah, this is saying this is so thick. The thickest standard I had was, well, this is good that this came up. This is basically saying, hey, this is really thick. This is pretty far outside of the calibration standards that were used. So it's just kind of warning you that it might not be super accurate on this high end. And you can say, okay, it'll, yeah, give you an out of range. Because I think the thickest standard I had was like 240 microns. So, but it will still calculate the percentages. But this energy cal, run this. I've got it set to run on to remind you on a monthly basis. If you want, I could change it to weekly, whatever you all think. But monthly is totally fine.
Does it keep track of it when we do that?
It does. It
So
does.
you can
There's
get
a log.
list, you get a
Exactly.
log.
There's a log file. Yep. But when it reminds you to do it, just go here to energy cal, and then just put it in just like it's a regular sample. Try to get right near the middle. You don't have to be exactly in the middle. And again, just hit measure. I literally just got this software 3 days ago.
And about a 30-second measurement time usually
Yeah, 30. So it's set for 30 seconds.
for that sample size.
Yes, exactly, for this particular routine. And what will happen is, if it is within the, basically what I calibrated it to today, it's looking at peak location. Yeah, this is 10 over copper. I don't think I mentioned that. 10 plated over copper. So you've got your copper peaks here, and you've got a 10 peak here, and 10 peaks out here. If it's within plus or minus like 2 channels for each one of those peaks, it'll just do this 30-second check and say, hey, you're good. But if something had drifted a little bit, it'll run for about another 3 minutes, just to kind of dial everything back in. Because over time it will drift a little bit, but shouldn't drift much at all. I mean, it's probably going to say this 99% of the time. So you can just say okay, and then that did store it to a log file. So there's nothing you have to actually do here other than just measure it, and it does everything automatically for you. And then you just go back to analyze. Qualitative analysis you may use from time to time. That's kind of like unknown analysis, just putting something in and it, just like on the EDS where it'll automatically identify the peaks. Same kind of idea here. You can do measurement time of, I don't know, whatever you want to start with. Pretty quick measurement time is fine for this. And again, just put it in there, click measure. This is brand new. I haven't really played around with it much, but it seems to do okay. Like a lot of automatic identifying things, if you're going to get false positives and false negatives, you just can't avoid it, but it's a good place to start.
Yeah. And it's pretty real time too.
Yeah. And then if you wanted to zoom in, you just hold the Alt button. If I wanted to zoom in here, hold the Alt button and just draw a little box, and that zooms in. I think now they've got it to where there was something, yeah, the mouse wheel kind of does it too, and if you want to reset it, just right click, when in doubt, right click. If you forget where something is, just try right click, go zoom and undo all zoom pan, and that'll just reset it to the standard scale. And then just if you want to clear them all, just hit clear all. So. And you can play around with the different collimator sizes here. You see all the different ones. The primary filter, just in case you're wondering, goes between the X-ray tube and the sample. It's meant to kind of filter out some of the tube characteristics, because this is a tungsten-based tube, so you're going to get a little bit of actual tungsten signal coming through. So the filter helps filter that out. The 0.1 is by default used. That's what I've had this set up for, so I would just leave it on that. You got your voltage and current. You can play around with. Over here, materials is another fairly new feature we've done. It would be if you wanted to make an alloy library, if you had a bunch of alloy standards and you wanted to load them in and show it, hey, this is 316, store that spectrum in the library, this is 304, this is 321. You can store those spectra in the library, then when you put in an unknown, it'll give you the best alloy match. So you can do alloy identification. So maybe not something you all would use, but just something that's there if you want it. So those are sort of your different ways to analyze samples, but I'd say most of the time, if not all, you'll just be in the analyze mode and just choosing the different applications. So what I'll do after we get done is I'll set up a gold application to where you'll have gold to choose from in here as well. Oh, and I don't think I mentioned, when you're done with your session, if you hit the little print icon, once you get a printer hooked up, it'll kick out a report. And let me see what it's going to do now. It's probably going to try to write it to a PDF or something. Just see what it... Yeah, it's trying to... Yeah, okay. You know what, let me do something here real quick. Turn off that. Okay, here we go. So this is just an example of sort of the default report template. You can change this around some. But basically it's just going to list all of the, let me take one more reading, and it's where you get some statistics on the screen. Now let's go back to my video, and let's see how well it, you can change measurement time right here too. Just going to do a quick one just for, you're doing good. I want to show you what this is going to look like with multiple readings. So when you hit print here, so once you get multiple readings, it does have all the statistics on there. And it does store a picture of each sample you test as well. And some of these, you could, if you didn't like the picture, you could have it removed.
Can you put the graph on there?
Yes, you can. Well, the spectrum itself,
Yeah.
unfortunately not in this report generator. You'd have to print screen and,
Okay.
well, actually, you can, if you really wanted the spectrum on there, you could do this. You can export this to different file types. I will say this though, you can export it to Excel, but the way it crunches things into columns,
Yeah.
it's kind of a mess. So I like the RTF because that's like a Word document format, and it's just cleaner.
Okay.
And then you can if you export it that way, or even PDF if you have Acrobat, whatever
Yeah.
you want to do. And then once you save that, you can go to the spectrum, right click, and save image as.
Okay.
And so just save the spectrum as an image, paste that in.
Okay.
Yeah. Or screenshot, whatever's easiest. So that's there. If you needed to change the settings, like if you wanted the default measurement time to, because once you change and go back, it'll default to whatever the test time was set at. If you go to the little settings, little gear icon here, it'll walk you through each of the sort of the different characteristics of this application. So you can change measurement time, change units, decimal places. This fit quality is another brand new feature. I don't trust it yet, so I just left it unchecked. Essentially, it's there as like a safety net for if you were using the wrong application. So if you put gold in and you were on the tin lead application, it should read the spectrum and say, whoa, 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 this is not gold, and it would give you an error. But I've seen it does a little too good of a job, even if you're on the right application. Sometimes it's just a little oversensitive right now, I think. So I believe it. You all are all smart, you'll be on the right application, right? And this one here, if you wanted to put in like an upper and a lower specification limit, like for that mil spec, if you want to put a minimum 3% lead, you go in here and put a lower limit of 3 on the lead composition, right? And then it would give you an error if it was below that. -1 just means there's no limit. This is where you can change the report template, change those different trace fields here. What do you all think about the ones that I put on there? Does that seem like
Yeah.
it'll work?
Yeah.
Okay. I put notes in just that way you could just kind of use that field for whatever. And then this screen is just going to say, hey, this is the name of the calibration file and the analysis file. I just named them the same. And you could change, if you needed to make a copy of it for whatever reason, you could, and just give it a new name right here. And then finish. And when you do that, it creates this icon here. It says, hey, you need to start your first session. Okay, fine. And there you have it. So I'll just delete that. Any questions about just running tests? Pretty easy, right? I mean, the main thing is just being properly located, you know, have the spot size right on your sample. Again, use that zoom or the mouse wheel if you have something really small. And then, you know, as long as it's auto-focusing properly, I'd just use that autofocus. And go with that. So everybody kind of, as far as normal sample operation, everybody's good? If you need to create a new calibration, you go to calibrate, and you can go create new, or you can add to an existing calibration. Either way, I'll open an existing first to kind of show you. Like if I just go to the 10 lead, the 12 mil, you can see over on the right-hand side. Okay, so any new, call it a calibration, call it an application, analysis file, recipe, whatever you want to call it, any new application you want to build, the minimum requirement is you have to have the pure element infinite for each element that's being measured, okay? Because you have to show it what a pure of that, you know, element looks like. Other than that, it's just adding standards that you might have in-house to dial in the accuracy over the range you're going to be measuring, right? So you all got a brand new 187 pure 10, and you got a brand new 240 microinch 9710 3% lead standard. And then you had an existing one that was, like I said, about 60-40. So I added those three in. So not saying you can only measure from 79 to 240, but like when we were measuring 4.5 mils, you can see that's very far away from our thickest standard. So that's why I think it was getting a little bit, you know, giving us those errors like, hey, this is really, really thick. And that was probably, that one's probably pure, right? It's not even, that was not even plated. That's why, because that's just a 10 lead puck, right?
Mm-hmm. Yeah, I believe so.
Yeah. So, but you know, this this range here is displayed in this curve, so you can see, like this is our 79, this is our 187, this is our 240. So you see, we're going all the way down to 0, and it's extending it all the way out to infinity. So you can measure anywhere in that range. It's just you're definitely going to be most accurate from, let's say, like I like to divide by 2, multiply by 2 kind of thing. Let's say from, say, 40 to about 500 or so. That's where you can expect the best accuracy thickness-wise. And then percentage-wise, you know, we have a 3% lead, and then we have a 38% lead. So you should be accurate within that range. You know, but I could, you know, look at maybe adding this in as a another calibration point as well, if you wanted to. But that's that. So you've got calibration curves for tin, you've got a calibration curve for lead, and those are there. But so that's an existing one. So if you wanted to add a new standard in, you go to your library tab here and just go to Add Standard. You tell it what type it is, like these that you all have are foils. You know, some customers have actual hard plated standards. If we wanted to add, just for instance, this one in here, plated doesn't matter because it's just a puck, right? You don't have to do the serial number or certification date. I tell people just work your way top to bottom. Thickness units doesn't matter because this one isn't plated. You just go to layer 1 and expand that out and say the thickness, in this case, is infinite, right? Because this is just a pure sample, it's not plated. And the composition is, it's 10, so I'm just going to drag that over, drop it right into where it says empty, and then lead, right? And you said this one is about 9% lead?
I believe it was 8.75. It should say on B.
Okay. Oh, yeah, you gave me the, okay, great. So this says 8.7% 10, but that is lead. Or is that?
I can't remember which
Okay.
one. It should be 10, yeah.
Okay, 8.710. Okay. Great. So if you put in the 8.7 on 10, you can leave lead at 0, and it'll automatically calculate the remainder. And then once you enter that in, you see it creates an icon for that. And if you want to add it to this calibration, you just drag it over and put it right there. And it's going to show up in white. You see we've got the sort of the color legend down there. It's showing up in white or kind of yellow. It's just showing it's a new standard that needs to be measured. So, and then you highlight that, you put it in, you measure it, and it adds that to the calibration curve. So,
Pretty much just as the closest one to 12 here.
and then if you want to remove it, just pull it off.
So 12. Yeah.
And here's where you can change your collimator size.
Now, does changing the collimator size do anything except restrict the amount of X-rays that are coming through? It just narrows down your field.
Yes.
That's the only thing. That doesn't make it more intense or anything, right? It doesn't make it.
No, because it's literally, there's a brass block and it has different holes that were
Right.
just milled through it. So it's literally just like an aperture.
Got it.
Basically.
Just
Yep.
focusing on
Yep.
the
It's
point.
just, so it's attenuating everything that can't make it through. Yep.
Okay.
So that's why the smaller the size, just the fewer X-rays get
Right.
through.
You have to run it either longer.
Exactly. So I set it up to run the 12 mil for 30 seconds and the other two smaller collimators for 60 seconds. And you all can play around with that. Something good to do, if I go back to analyze, and I'll just say no, we don't want to save this, is you can set up a repeat measurement. So do a repeat, and maybe do like 10 repeats. Try it out at different test times and look at your standard deviation and see what you can live with. You know, you don't want to be running it for 20 minutes, you know, but you'll...
Can you set it up where it'll stop automatically at a certain count?
No, it's based on measurement time.
Measurement time? Okay.
Yeah,
That's
yep.
not a problem.
But if you wanted to look at the counts, just to get an idea of what you're getting, pop this back in here. I'll show you. You can just scan that area just by left click,
Gotcha.
left mouse drag, and 3500.
Yeah.
You know, this is not quite as fancy a detector as you probably have in your EDS, so it's
Okay.
not collecting.
It's-
Yeah.
Yeah. That's why we have both. This
Yeah.
is different,
Right.
different objective.
Right. But yeah, it gets pretty decent count rates. Also, we got a relatively low power tube and a small spot.
Yeah. So it just overlays on itself, just different colors or something like that.
As far as
Oh, it's doing the repeat. Okay.
Oh, yeah.
Like the repeat will just graph will overlay over this one or something.
yeah, it'll just do
It'll
like a
give
running list here in the stats.
Oh, okay. That's
Yeah,
nice.
yeah.
Yeah,
So that's
let's
what I'm saying. Yeah.
see the difference. If
Yep.
there is a.
Exactly. Okay, I see now. So that was all right. And you know what we might want to do is, for just measuring pure solder, maybe I'll make one that's just tin lead, just a composition. There's no thickness.
Oh, right.
And we can do that together. That'd be a good one to do together. But now I understand. I was thinking that was flipped. So I can definitely see why this is not super accurate, because that's really far away.
Yeah, from the standard is the opposite.
Yes,
that you're
exactly.
on there right now. That
Yeah.
makes sense.
Yeah. So, anyways, but you get the idea. So,
Yeah.
so for like percent lead, we can look at that standard deviation. You could the standard deviation, because this is all based on counting statistics of the photons. So it's an inverse square relationship. So if you wanted to cut your standard deviation in half, theoretically you multiply your test time by 4, right? So just is a just rule of thumb for so. So yeah, I'll set up a, why don't we just do that together real quick? Because this is set up to measure thickness and composition of tin lead plated samples, right? But if we go to calibrate and create a new calibration, because I didn't even do this, did I? You can see here the number of layers. So we can do multiple layers, like I can do gold over nickel over copper and get the gold and the nickel. But if you do a single layer application, and if we just drag tin and lead and just simply drag and drop it, if you had multiple layers, then you just drag it to wherever it is. If it was gold, nickel, copper, just how they're plated, you know, so just how the cross section would be, just like that. Right, click clear elements. But for just getting composition, just drag tin and lead in here. Go to next. It gives this tutorial the first time showing you how to drag standards over. It'll pop up every time. I think you all are going to get this. I'll just dismiss it. But here's that that one that we made in the library. I'll drag that over here. And again, it's showing up as a new standard we need to measure. We'll use the biggest spot size here because I would assume you're going to be doing larger samples just for composition. And then just go over here and measure it. It defaults to 60-second measurement time in the calibration routine just to get a good long measurement. Honestly, for the 4 mil or the 2x10, the smaller collimators, you might even want to think about, for the calibration, bumping it up to maybe 90 or 120 seconds, just so you get a really good representative spectrum in your calibration step. But for the 12 mil, 60 seconds is plenty. But yeah, any other concentration ranges? I mean, in an ideal world, you'd have something that's maybe 50-50, and then something that was, 90-10, and then maybe something that was right at 3%. I mean, more than about 3 or 4 standards is kind of overkill, because it really does do a good job interpolating over the full range. But, if you have them, you might as well add them in. But I'd say, especially with the 3%, you'd want to.
That makes sense now.
Yeah. So once it's done, it turns green, just meaning it was measured live in this. You noticed that it pulled these from the library. So once you measure them once at that collimator size, it stores the spectrum, and so you don't ever have to measure those again. So
is this all saved now? That calibration is saved, so.
Good question. Not quite yet. So the spectra are saved. They're done. But if I try to go over here, it's going to say, whoa, 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 you didn't save this. All right. So if I hit cancel, what you normally want to do, it is protected like that, but you want to go file to save or save as. Doesn't matter the first time. And what would you want me to call this? Just tin lead composition?
Yeah, exactly.
And I always like to put the collimator size in. I mean, you can see it on the screen, but that way you just know what you're working with. And hit save. So now we've got our calibration file saved. Okay. And if we go back to analyze, these, that's our cal file, but these down here are called application files. So you can have multiple applications from one calibration. The idea being maybe one customer says, hey, you got to measure this for 180 seconds. That's our rule. Another customer doesn't care, so you've got different copies, or one wants a specific report type, another one doesn't care. That's the sort of the idea. So the calibration is really your regression curve, it's your standards that you use, it's all the real quantitative stuff. The application is just sort of what do you want to do with that, all right? So the way to make an application file is you go back to Analyze once you've saved your cal file, and you open up that cal file. So if you do by date modified, it'll always be the last one at the top. So you see we got CalX and AppX files, right? So we want to open this up, and then we go right back to the wizard where it'll walk you right through it.
Gotcha.
And I'll just do maybe 20 seconds, should be plenty on this. However many decimal places you want. And it just walks you right through, Again, if you wanted to put in your specification limits, you can do that here. Yeah, I like to use the report that we made that has your info on it, so just go find that one, and then just choose that only trace selection that we have, and then this is just going to name it the same as the cal file, and then finish. Okay, fine, we got to do our first session, good, and you see now it made that application, and now we should get, of course, we should get really right on now, of course, kind of cheating, but yeah.
Okay.
You'll see on the bottom of the screen, I know it's kind of tough to see here, but this is kind of like your status of the different hardware components. I like to point this out though. You got, your detector is being cooled down to almost minus 60 Celsius, a little LTA cooler. So yeah, so now we can, of course, figure that out. But yeah, it's kind of the idea, cal file, add standards, save it, go back, open the file in analyze mode, and then it walks you right through setting up the application.
Is there any reason the dead time would change, or is it be automatic?
Yes, no, it's a good question. So you'll notice when we measure, probably going to be running at, I don't know, maybe 10% dead time or so.
Yeah, it was around 7.
Yeah, okay. So that's going to be based on the the amount of counts you're getting according to you know how that works, and it's definitely going to change. If you're using the 4 mil collimator, that'll be way down like 1%. But we used to have an optional 60 mil collimator that we sent out, but it would saturate the detector. It'd be at like 60-70% dead time, and as you know, your peaks start to shift and stuff. So we say just try to keep it below 40%, but there's no way with this collimator size you'll ever reach
The only
that.
thing that would change it would be the collimator.
Exactly.
Yeah.
Yep.
There's no can't brighten up.
Not really. The primary filters, this is on the thinnest one already, so you're getting the most counts you can.
Yeah. Okay.
But yeah, if you did a thicker primary filter, it would drop it down even more.
Gotcha.
As far as maintenance, regular things to do, other than running that energy cal at least once a month, there's really nothing you need to worry about. We come in annually and give it a good, once over, clean things out, recertify it and all that good stuff. And we found no issues with only coming in once a year.
So you just got annual maintenance on it?
Exactly, yep. I have found these systems to be incredibly stable over time, but then again, and it's an electronic system, things can go weird. So just, on a regular basis, just verify your standards, that they're measuring back accurately. But I think you'll see that you really shouldn't need to recalibrate, meaning go into the calibration file and remeasure your standards to kind of like refresh it. Maybe once or twice a year, maybe. It depends on how tight your tolerances are, But typically, all the standards should measure back, definitely within plus or minus 10%, usually within 5% accuracy. Of course, that does depend on the test time, but for 1 second measurement, it's going to bounce around a lot. But I think 20-30 seconds with the 12 mil collimator, you'll see is going to be plenty for what you need.
So we'll go ahead and we'll stop at 12:30.
Okay.
Lunch, then we'll reconvene, and these guys can do an actual demo.
Okay, yeah.
If you have any questions.
Sure, sure. questions for now?
You good? You want to pause this or no?